360 minus that, I'm fine with that.
What is the negative?
Because it's landing at that angle right there. 0 degrees, 90 degrees, 180, 270, 360, or 0, negative 90, and so on. If you gave it as a positive angle, that means it's hitting the ground, going in that direction.
Oh, okay.
Which I think would mean there is a rip in the space-time continuum, which is out of the scope for this class. Unless you want me to do the problems. No, okay.
Are we able to, pick up where we left off with our lab yesterday, the rest of us?
I was not picturing that. Questions? All right, I'm gonna do one variation on this problem. Instead of 50 here, I'm gonna do 500. We're not gonna do the whole thing ever again, but with that will 500. That changes, that's gonna change. That's all the same, that's gonna change. That's gonna change. Well, we've already got that information written down. That's the same. All right, and I just erased that, and I didn't mean to, there we go. All right, so what's gonna change on here?
Delta S would be negative 500.
Yeah, so we got an extra 0 there. And that 0 shows up here and then here. So let's just get the times, and then I'm gonna change the problem slightly. So let's get like this. Oh, no problem. We'll find out when it takes off. Wow. That's you. Good. All right, so what do we get for the positive time?
17.9. So I got.
17.9?
Yeah.
Actually, I write that better. Okay. Assuming there's no mistake there, it's, I would have expected if we increase this by tenfold, it only increased by half. But I guess it is going a lot faster. All right. Now let's suppose you make a mistake. Instead of negative 500 here, you just write down 500. Which means that this is a positive 500, which means that's positive 500, which means that's positive 500. What would the answer be now?
Imaginary.
And how would you know that?
Because you're going to have a negative under the radical.
Yeah. So if you got a negative under the radical, that's one of two things. One, it means one of two things. It means you made a mistake somewhere. Or two, it's an impossible problem. Do not, please, do not get a negative under the radical and go, well, my calculator can't handle that. Why don't we just make it a positive number and keep going? Get negative under the radical. You made a mistake, but the problem's not possible. One way that you can sort of think about that is if I shot this off a cliff, does it make sense that it can land down below from where I shot it?
Yes.
Therefore, there should be a real answer. So the negative under the radical means I've made a mistake somewhere. If I shot this up like this and I said, at what time is it 500 meters above where it started, then the negative under the radical means it's not possible. It doesn't get that high. All right, questions here?
Even you change I'm assuming you changed the numbers to show us that it could be, if we made a mistake, that it could be radical if the numbers were big enough.
Yeah, that you could get an imaginary answer, yeah. All right, all the rest of the chapter 3 problems are basically variations of this. Please watch the videos. Of course, I shouldn't have to ask that since this is only a small fraction of class time. The rest of them are from videos, but this is the simplest projectile motion type problem, where I give you initial velocity and ask you information about the end. Here's my thinking when I get to writing the test. I'm thinking, we've done this. Everyone in the class can do a problem like this. Let's mix it up. How about if I give that information and ask you to find this information? And then that leads to, I think I have one video labeled as the hardest projectile motion problem. Anyway, they're just variations of this, but it's all still basically the same type thing. It comes down to the math. Is there anything else I want to talk about in chapter 3 before we press on? I think that was it. Any questions before I start talking about, so that plus the videos is the material for the first test, test 1A.
When is our first test?
When do you want that first test?
Never.
Yep.
For
We
my
can just
mental
get one
health.
giant test at the very end. I cannot imagine that's gonna work better for you though. Not for vigorously shaking our head no.
2 weeks from now.
Okay?
I had a question. You know who's right down under the velocity J hat and then under H with the I hat? The one that we didn't fill in, was that supposed to be 0?
For,
So the other side, it was like negative 50 meters. So was the other side supposed to be 0?
oh, right here?
Mm-hmm.
No, this is, in the first problem, it was the 1,042.4 meters.
Okay.
This would be how far it goes out horizontally.
Okay.
Other questions?
So, our pre-lab and the master set is due tomorrow.
Ah, that's right, thank you for bringing that up. All right, so if we want to make this test in 2 weeks from today, I guess we got a 2-hour slot Tuesday, Wednesday, Thursday. So I have no problem. All right, so the test 2 weeks from today. And I have no problem with the master set being handed in on Tuesday instead of tomorrow. the lab, the graphing lab due on Tuesday, and Master Set 3 due on Tuesday. If you've already done Master Set 3 or still want to get it done for tomorrow, feel free to hand it in or submit it online.
But the pre-lab's due tomorrow.
Yes, the pre-lab is due tomorrow.
Are you starting another lab tomorrow?
Did I post one? I'm trying to remember.
There's not one on the announcements.
Yeah, we haven't.
It seemed like that there was something posted, but it said like no pre-lab for this.
The linear motion.
Yeah, it's there in the lab section.
Yeah.
Doing that one tomorrow.
I reserve the right to change my mind, but yes, that'll be the next one that we do.
Linear motion. Part 1.
And even though that is something, that particular lab can be done, it is possible to do solo, if you understand the material. I think there's value in the group discussion as in the smaller groups.
Oh, per the syllabus, it does say we take test 1A 2 weeks from now.
Oh, okay.
Yeah.
Oh, okay. That's sort of a shock.
Damn, I'm good. Well, it's April 4th. It's a Tuesday.
Should be
You want it on Tuesday instead of Wednesday?
I mean, if you wanna make it April 1st and just say it was a joke, I'm good for it.
It'll be proctored by Sid Finch. Anyone know who Sid Finch is?
No idea. How old are you?
Considerably older now. It was a April Fool's joke done by Sports Illustrated. Sid Finch was this very eccentric pitcher for the Mets, supposedly. Pitched with one boot on, one barefoot, to throw the ball 140 miles an hour. There were some Mets fans in the dorm who got really excited, and then it came out it was an April Fool's joke, and they were very mad. All right. As far as due dates go, Master Set 3, my feeling is I'm not gonna change the due date in Blackboard, but since you could submit it on Blackboard after the date, I mean, just know it's due on Tuesday.
Can we start chapter 4 next week, right?
No.
Tomorrow?
Now.
Now?
Yeah, we're gonna do chapter 4 right now. At least the basics. It's the dream of physics teachers to be able to teach chapters 2 through 5 all at once. Because they're so really interlinked. That's why, if you look at the old test, and I have test 1, it was covering basically chapters, in essence, 2 through 5 or 2 through 6. Because they do go really nicely together. They both set up the foundation of the course. It was too much of it. It was just seemed to be too much material, and that's why I split it into 2 tests. Test 1A, and I still call it Test 1A and Test 1B. They are 2 different tests. It's not half of a test and another half of a test. They are 2 different tests. But I call them 1A and 1B at this point for historical reasons. But Test 1, if you see something that's labeled Test 1, that is covering material from basically Test 1A and 1B.
Are we going to have like a test review?
If you have questions, I will be glad to answer them. I was not planning to do a test review if people don't have questions.
So, what units exactly are test 1 at?
Test 1A is chapters 2 and 3,
And is 1B 4 and 5 or 4, 5, and 6?
4, 5, and 6. Other questions? All right, so somebody tell me what a force is.
Mass on acceleration.
Does that really tell you what a force is? More specifically, what is, all right, F equals ma, it's an incredibly important formula. What force is that?
Force of a moving object?
The force of a moving object?
Yeah.
Uh,
Of an object in motion, I guess.
It does not have to be an object in motion. And surely not a force of the object. You have forces on an object and by an object, but not of an object.
Okay.
All right, spoiler alert, an F equals ma force, that's the total force. That doesn't tell us really what a force is. That's, if you add up all the forces on an object, that is going to be equal to the mass of the object times the acceleration of the object. All right, so, are there forces acting on you right now?
Yeah.
Yes.
All right, let's try to get this one out of the way. Gravity is not a force. Weight is a force, force due to gravity is a force, but gravity is a huge topic of which forces is part of it. So, how do you know that the force of gravity is acting on you?
Did you say weight is a force?
Yes.
You stay on the ground, you're not floating, that's not where no gravity's effect.
When you jump, you don't jump to the moon, you come back down.
Okay, that's probably better, because if the world were flat, it's possible that we just kind of hang here. But if you do jump up, you do come back down. What about right now? Are there other forces acting on you other than the force due to gravity?
The normal force?
And what's that?
I guess opposing force, as you, like, if you sit in a chair, there's a force going upwards.
Okay, I'll buy that one. You said opposing force. Opposing what?
Gravity.
Ooh.
Oh, wait, no, that's not. Opposing your.
If you can break yourself of that habit early, that is more power to you. That is I've seen way too many times, and I'm overreacting, but I've seen way too many times students who automatically put normal force opposite the force due to gravity, and that is not always the case.
The force due to weight?
Weight is force due to gravity. Force due to weight is somewhat redundant. All right. Normal force opposes what?
Like contact? Like things where,
Pardon?
like two things that touch each other?
So what's opposing?
Two objects?
We're almost there, but
It's like an action and reaction force?
that's a separate topic. It's related, but it's a still a separate topic. It is the force that keeps you from going through another object. More specifically, there's a normal force acting on my hand, keeping me from going through the wall. Likewise, I'm exerting a force on the wall, keeping it coming through me. So, how do you know if that the normal force is acting on you?
Because you don't go through the wall when you put your hand on it.
Well, right now, what about now? Where you are? You, specifically, Cooper.
I'm not going through the chair when I'm sitting on it.
And,
The chair's not going through me.
okay, both valid. Maybe this has devolved into a read my mind exercise. Can you feel the chair touching you?
Yeah.
Okay, so there's one thing there that sometimes you can feel forces. All right. There's a formal definition, and then there's the actual usable definition. The formal definition, which I'm not going to write down, it is an influence that might cause acceleration. And I find that completely useless as a definition. A better working definition, in my opinion. Push or pull. I guess I could expand that push or pull or drag. Now, at this point in the course, there's basically four forces that we're going to be dealing with. And then sort of a checklist. FTOM, Fort Nog, whatever you want to come up with here. And I know I said we're 4 forces, but I have 5 letters here. Well, let's work through them. This F is for friction. T for tension. For those of you who've had physics before, did your instructor tell you that tension doesn't exist? Okay. There's a video where I discuss that. N for normal. G for gravitational. And then pesky O. I needed a vowel, but O is for other. Now there are a couple of rules. And here's an incredibly important one. Forces always. I really can't use that too often. Always come in pairs. And in that pair, each force in that pair is the same type. In other words, they're both friction forces, or both normal forces, or both gravitational forces, etc. The same type, same magnitude, opposite directions. If you can internalize this, it'll save you a lot of heartache later. All right, so each of these forces has a certain requirement. Actually, let's do simple.